Hello, in this lecture we will find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 5 units, side AD equals to 3 units, side AC equals to 6 units. Angle ADC, this angle equals to 90 degrees, and also angle ABC, this angle equals to angle DCB equals to theta, and we want to find out the length of line segment X that is actually equals to BC. So we'll start with the first method. In the first method we will do a construction. We will extend side BA and side CD by a straight line until they intersect with each other. We will define the intersection point or the touching point between extended line segment BA and extended line segment DC as point E. And actually here we created the triangle EBC. In this triangle EBC we have two angles that are equal to each other. Both those two angles are equal to theta, and we have rule number 1 that is related to two angles that are equal in the triangle. So according to rule number 1, in front of equal angles in the triangle there are equal sides. I'll write it down. So I'll write rule number 1 again. According to rule number 1, in front of equal angles in the triangle there are equal sides. So here in triangle EBC, we know that angle EBC, this angle, angle EBC this angle equals to angle ECB, and they are both equal to theta. I'll repeat again. Angle EBC equals to angle ECB, and they are both equal to theta. Therefore, according to rule number 1, in front of those two equal angles, they are equal size. That is to say, according to rule number 1, side EB equals to side ED. Side EB equals to side EC. Okay. So this will be equation number 1. EB equals to EC is equation number 1. And side EB equals to 5 plus AE. I'll write it down. While side EC equals to 6 plus ED. Here we will subtract 5 from this equation number 1, and we get that according to equation number 1, AE equals to 1 plus ED. Okay. Here we will define ED as A. ED equals to A according to our definition. ED equals to A. So we will substitute ED by A in equation number 1. And we will get that according to equation number 1, AE equals to 1 plus A. AE equals to 1 plus A. AE equals to 1 plus A. Okay. So here, before the construction, we had quadrilateral ABCD, and CD is one side of quadrilateral ABCD. So CD as a side of a quadrilateral must be a straight line, and when we extended the straight line CD by a straight line, the result must be a straight line. That is to say, EC is also a straight line. Okay, so we can write down that EC is a straight line because when we extended the straight line CD by straight line, the result is EC. And when you extend a straight line by straight line, the result must be also a straight line. So EC is a straight line. I'll write it down. Line segment EC is a straight line. And we have also rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. So I'll read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that EC is a straight line. So if we focus on this side of the straight line EC at point D, and this point D, then the sum of the angles here must be equal to 180 degrees. Okay? So at point D, at this side of the straight line EC at point D, which angles we have? We have here 90 degrees. We have also here angle EDA, this angle. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. That is to say, 90 degrees plus angle EDA, this angle must be equal to 180 degrees according to rule number 2. So here we'll subtract 90 degrees from this equation, and we'll get that according to this equation, angle EDA, the missing angle, equals to 180 degrees minus 90 degrees is 90 degrees. So this angle is a right angle, it is equal to 90 degrees. So if angle EDA equals to 90 degrees, it means that the green right triangle is a right triangle. Therefore, we can implement the Pythagoras theorem in the green right triangle, triangle EDA. So, in the green right triangle, triangle EDA, by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is AE, therefore the square of the hypotenuse is AE squared. And it must be equal to the sum of the square of the perpendiculars, that is to say, it must be equal to AD squared plus ED squared. AE equals to 1 plus A, therefore AE squared will be equal to 1 plus A squared. And it is equal to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus ED squared. ED equals to A, so ED squared equals to A squared. So in conclusion, we found out that according to equation number 2, 1 plus A squared equals to 9 plus A squared. Here we will open the brackets on this side of equation number 2, and we get that according to equation number 2, 1 plus A squared equals to 1 plus A squared plus 2A, and it is equal to 9 plus A squared according to equation number 2. Here we have A squared on both sides of equation number 2, so A squared will get cancelled. And we're left only with 1 plus 2A, that is equal to 9. Here we'll subtract 1 from this equation number 2, and we get that according to equation number 2, A equals to 9 minus 1 is 8. Here we divide this equation number 2 by 2, and we get that A equals to 8 over 2 is 4. So we found out that A equals to 4. Right here, that A equals to 4. And 1A plus 1 is 5. In the next step, we will define angle AED. This angle is alpha. So we will focus on the green right triangle AED. In the green right triangle AED, cosine alpha equals to ED over AE. I will repeat again. In the green Right triangle AED, cosine alpha equals to ED over AE. If AD equals to 8, that is 4, and AE equals to 1 plus 8, that is 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. I'll repeat again. We found out that cosine alpha equals to 4 over 5. In the next step, I will present to you a new law, that is the law of cosines, and we will implement the law of cosines in this triangle EBC. The law of cosines is true in any triangle. So if we have a triangle ABC that could be any triangle, this is triangle ABC. And we know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. Then, and we also know that the angle between side AB and side AC is alpha. Then, according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. This equation is true in any triangle. So we'll implement the law of cosines in our triangle EBC. Here EB equals to A, EC equals to B, angle alpha is angle alpha, of course, and BC equals to C, that is actually equals to X. And we also know that EB equals to 5 plus 5, that is 10. And EC equals to 4 plus 6, that is also 10. So, according to the law of cosines, we get that C squared is BC squared, that is actually X squared, equals to a squared. A squared is EB squared plus B squared, that is actually EC squared, minus 2 times EB times EC times cosine alpha. So here we have already found out that cosine alpha equals to 4 over 5, so I'll write it down. Cosine alpha equals to 4 over 5. This will be equation number 3. So according to equation number 3, BC square, BC equals to x, so BC is x squared, so BC squared is x squared, and it is equal to EB squared. EB equals to 10, so EB squared is 10 squared, that is 100, plus EC squared. EC equals to 10, so EC squared equals to 10 squared, that is 100, minus 2 times EB is 10, and EC is also 10, times cosine alpha, but cosine alpha equals to 4 over 5, so we'll substitute cosine alpha by 4 over 5. So in conclusion, according to equation number 3, we got that x squared equals to 100 plus 100 is 100 plus 100 is 200. Minus 10 times 10 is 100, 100, and 100 times minus 2 is minus 200. So it is minus 200 times 4 over 5. So, according to equation number 3, we will get that x squared equals to 200 minus 200 over 5 is 40, so it is minus 40 times 4. So according to equation number 3, we get that x squared equals to 200 minus 40 times 4 is minus 160, and 200 minus 160 is 40, so we got that according to equation number 3, that x squared equals to 200 minus 60 is 40. We'll take out of this equation number 3. And you'll get that according to equation number 3, x equals to the square root of 40. 40 is 4 times 10, so we substitute 40 by 4 times 10. And the square root of 4 is 2. So according to equation number 3, we will get that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So the answer to the question is that x, the length of line segment x, equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we can write here that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the depth of line segment x according to the second method. The second method, we will do another construction. From point A, we will draw a straight line on DC in such a way that the straight line will be parallel to BC. Okay, so here we define the touching point of the straight line from point A and DC is E. So actually, according to our construction, AE, side AE is parallel to BC. So I write it down. AE is parallel to BC according to our construction. In the next step, from point E, we will draw a straight line on BC in such a way that the straight line will be parallel to AB. We will define the touching point of the straight line from point E and BC as F. So here, I repeat again that EF is parallel to AB. So we drew the straight line in such a way that EF is parallel to AB. So I write it down that EF is parallel to AB according to our construction. So quadrilateral AEBF that we created here is a parallelogram. Why? Because it has two couple of sides that are parallel to each other. The first couple of sides that are parallel to each other is AE is parallel to BF, and the second couple of sides that are parallel to each other in this parallelogram is AB is parallel to EF. And this is exactly the definition of a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram. In the first step, I will present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. I'll write it down. So, let's read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here, according to our construction, AB is parallel to EF. Therefore, according to rule number 3, those two angles that are defined as corresponding angles and and located, those two angles are located, they are corresponding angles, and are located between the parallel lines A, B, and EF, will be equal to each other. So here, angle ABC, this angle, is equal to this angle that is actually angle EFC. I repeat again, angle ABC equals to angle EFC according to rule number 3, of course. But here, angle ABC equals to theta according to what is given us in the question. So we can write here that angle ABC equals to theta, and from this equation, theta equals to angle ABC equals to angle EFC. We will derive that angle EFC is also equals to theta. So we can write here that angle EFC equals to theta. Likewise, we have, according to our construction, AE is parallel to BC. AE is parallel to BC according to our construction. Therefore, those two angles that are defined as corresponding angles and are located between the parallel lines AE and BC will be equal to each other. That is to say, angle AED, this angle, will be equal to this angle that is actually angle DCB. And they are equal to each other according to rule number 3, of course. So I write it down. But if angle DCB, this angle, equals to theta according to what is given as the question. So we can write here that angle DCB equals to theta. And from this equation, angle AD equals to angle DCB equals to theta. We will derive that angle AED is also equals to theta. So we can write here that this angle AED equals to theta. So here we will focus on triangle EFC. Actually here I didn't write that AB equals to 5 units according to what is given as the question. So, before that I will present to you a new rule. This is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. The opposite sides of a parallelogram I will read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So here we know that quadrilateral AEBF is a parallelogram, so I write it down that here P is the abbreviation for parallelogram. So in parallelogram AEBF, we know that AB is parallel to EF, or AB is the opposite sides of EF. Okay? AB is the opposite sides of EF, therefore AB is equal to EF, according to rule number 4. I repeat again. According to rule number 4, AB is equal to EF because side AB is the opposite sides of side EF, and the opposite sides of a parallelogram are equal to each other. That is to say, AB is equal to EF according to rule number 4, but AB equals to 5 units according to what is given in the question. And so from this equation 5 equals to AB equals to EF, we derive that EF is also equals to 5. Here EF equals to 5 units. In the next step we will focus on triangle EFC. In triangle EFC, we know that angle EFC is equal to angle ECF and both angles are equal to theta. Okay, so therefore, according to rule number 1, that in front of equal sides, in front of equal angles in the triangle there are equal sides, we get that EF is equal to EC. EF equals to EC according to rule number 1. That in front of equal angles in the triangle there are equal sides. But we know that EF equals to 5. EF equals to 5. So from this equation 5 equals to EF equals to EC, we derive that EC is also equals to 5. EC is also equals to 5 units, so we can write here that EC equals to 5 units. So what is the length of DE? What is the length of DE? It is very easy to see from the drawing that DE equals to DC. Again, DE equals to DC minus EC. Again, DC minus EC equals to DE. So write it down. I repeat again that DE equals to DC minus EC. So actually, DE equals to DC, that is 6 units, minus EC, that is 5 units. 6 minus 5 is 1, so DE equals to 1 unit. DE equals to 1 unit. So I can write here that DE equals to 1 unit. In the next step, we will implement the Pythagoras theorem on the right. Triangle ADE. On the right, green triangle ADE. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE squared AE squared equals to AD squared plus DE squared. So, according to question number 1, AE squared equals to AD squared. AD equals to 4 units according to what is given in the question, so AD squared is 3 squared, it is 9, plus DE squared. DE equals to 1 unit according to what we just tried now found out, So d squared is 1 squared, that is 1. So in conclusion, according to question number 1, I actually found out that a squared equals to 9 plus 1, that is 10. We take out of this equation number 1, and we get that AE equals to the square root of 10 units. So we can write it that A equals to the square root of 10 units. Now we'll use rule number 4, that the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF according to rule number 4. In parallelogram AEBF, according to rule number 4, A equals to BF. A equals to BF according to rule number 4. But we have already found out that A equals to the square root of 10 units. So we can write here that A equals to the square root of 10 units. And from this equation, square root of 10 units equals to A equals to BF, we derive that BF is also equals to the square root of 10 units. Okay? Here, BF is equals to the square root of 10 units. And what is the value of line segment FC? It is very easy to see from the drawing that FC equals to BC minus BF. I'll repeat again. FC equals to BC minus BF. So FC equals to BC, that is X, according to what is given in the question, minus BF. We just right now found out that BF equals to the square root of 10 units. So, actually we found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. This is the value of side FC. we'll focus on triangle EFC. Actually, triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC equals to 5 units. So we write it down. Triangle EFC is an isosceles triangle. I repeat again, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. And the base of the isosceles triangle EFC is side FC. I write it down that FC, side FC is the base of the isosceles triangle, triangle EFC. So, in the next step, we will draw perpendicular from point E on FC. Okay? From point E, we will draw perpendicular on FC. And we will define the touching point of the perpendicular from point E and FC as M. So here actually this angle equals to 90 degrees and this angle will be also equal to 90 degrees according to our construction because of the fact that EM is perpendicular to FC. So we can write down. So, what is actually line segment EM? Because of the fact that EM is perpendicular to FC, it means that EM is the height to the base FC. So, write it down. EM is the height to the base okay, we can write here also that this line segment EM is the height to the base. To the base is and the base is actually FC. So in the next step I will present to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. We'll write it down. The height to the base in an isosceles triangle bisect the base. So I'll read all over 5 again. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So here we have the isosceles triangle EFC, and EM is the height to the base. So the height EM to the base FC bisects the base FC. That is to say, it divides it to 2 equal parts. So if side FM equals to FM over 2, then side MC will be equal to also to FC over 2, of course. It divides FC into 2 equal parts. So the first part must be equal to FC over 2, and the second part must be also equal to FC over 2. So first of all, because of the fact that the height EM to the base FC bisect the base, it means that FM equals to MC according to rule number 5. FM equals to MC according to rule number 5, because according to rule number 5, the height EM bisect the base. It means that it divides the base into 2 equal parts. That is to say, FM equals to MC according to rule number 5. And because of the fact that it bisects the base, it means that each part will be equal to FC over 2. So FM will be equal to FC over 2, and MC will be also equal to FC over 2. So in conclusion, according to rule number 5, FC over 2 equals to FM equals to MC. Why? Because here the height EM bisects the base FC. So each part, so FC is divided to 2 equal parts. So this part FM will be equal to FC over 2, and MC will be also equal to FC over 2. And those 2 parts, they are equal to each other because of the fact that the height EM bisects the base That means that Fm equals to MC. Okay, so in conclusion, we found out that FC over 2 equals to Fm equals to MC according to rule number 5. So according to rule number 5, MC equals to Fc over 2. Fc equals to x minus square root of 10 and if we divide it by 2, we'll get the value of MC. So in conclusion, MC equals to x minus square root of 10 over 2. Here MC equals to x minus square root of 10 over 2. Okay, so in the next step we'll prove that right big triangle EMC is similar to the right small green triangle ADE. So we'll prove that those two right green triangles are similar to each other. First of all, in the green right triangle EMC, we know that this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right green triangle to 180 degrees. This angle must be equal to 90 degrees minus theta. Likewise, for the same reason, in the right triangle ADE, this angle equals to 90 degrees, this angle equals to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in the right triangle ADE to 180 degrees. This angle must be equal to 90 degrees minus theta. So actually, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle DAE I'll repeat again, angle DAE, this angle equals to this angle that is actually angle MEC, and they are both equal to 90 degrees minus theta. I'll repeat again, angle DAE equals to angle MEC equals to 90 degrees minus theta. In addition, we have those two angles that are both equal to theta, therefore they are equal to each other. So angle DEA equals to this angle that is actually angle ECM, and they are both equal to theta. I will do it again. angle DEA equals to angle ECM, and the above equal to theta. And finally, we have those two angles that are both equal to 90 degrees, therefore they are equal to each other. So angle EDA equals to this angle that is actually angle EMC. And they are both equal to 90 degrees. I'll repeat again, angle EDA equals to angle EMC equals to 90 degrees. So we proved that those two angles are both equal to 90 degrees from theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And both those two angles are equal to theta, therefore they are equal to each other. So all the angles of triangle EDE can go into all the angles of triangle EMC. Therefore, triangle ADE is similar, this is the sign of similar to triangle EMC. According to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that AE over EC equals to DE over MC. I'll repeat again, from the fact that triangle ADE is similar to triangle EMC, we conclude that AE over EC equals to DE over MC. A equals to square root of 10 units, EC equals to 5, D equals to 1 unit, and MC equals to x minus square root of 10 over 2. So in conclusion, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the numerator, to the denominator, and we get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10 Here we cross multiply this equation, equation number 2, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2 is 10. 10 is square root of 10 times square root of 10, so I write it down. We get that square root of 10 times x minus square root of 10 equals to 10, that is square root of 10 times square root of 10. Here we divide this equation, equation number 2, by square root of 10, and we get that square root of 10 over square root of 10 is 1, so we left here only with x minus square root of 10. And it is equal to square root of 10 times square root of 10 over square root of 10 is square root of 10. So here we add square root of 10 to this equation, equation number 2. And we get that x equals to square root of 10 times square root of 10 plus square root of 10 is 2 times square root of 10. So x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay. So we found out that x equals to either 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. Here x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. So we finished with the second method. In the next step, when we summarize the lecture, we'll start with the first method. So I'll repeat on the question. We have here quadrilateral ABCD. Side AB equals to 5 units, side AD equals to 3 units, DC equals to 6, and we want to find out the length of side BC, that is actually equals to x. We also know that angle ADC equals to 90 degrees, and angle ABC equals to angle DCB equals to theta. So in the first step we did a construction. We extended side BA and side CD by straight line until they intersect with each other at point E. Okay, and so here we have a triangle EBC that has two angles that are equal to each other. Both those two angles are equal to theta according to what is given as the question. So in the next step I presented to you a new rule, that is rule number 1. According to rule number 1, in front of equal angles in a triangle there are equal sides. So we'll focus on triangle EBC. In triangle EBC we have two angles that are equal to each other, therefore according to rule, so here we can write down that in triangle EBC, angle EBC equals to angle ECB equals to theta according to what is given as the question. Therefore according to rule number 1, if in front of those two equal sides, in front of those two equal angles, there are equal sides. That is to say, EB is equal to EC according to rule number 1. EB equals to EC according to rule number 1. But EB equals to 5 plus AE, and EC equals to 6 plus ED. Again, EB equals to 5 plus AE and EC equals to 6 plus ED. We subtracted 5 from this equation number 1, and we found out that A equals to 1 plus ED. Then we defined ED as A. Here, ED equals to A according to our definition, and we substituted ED by A in equation number 1, and we got that AE equals to 1 plus A. Here, AE equals to 1 plus A. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, actually, before we did the construction here, we had quadrilateral ABCD. In quadrilateral ABCD, CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. And then when we extended the straight line CD by a straight line, we got line segment EC. And when you extend a straight line by straight line, the result must be a straight line. Therefore EC is also a straight line. So you can write down that EC is a straight line, and then we have rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. So here we'll focus on this side of the straight line EC at point D. Here, according to rule number 2, the sum of the angles at point D on this side of the straight line EC must be equal to 180 degrees. So which angles we have? At point D we have here 90 degrees, and we have here angle EDA. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Again, 90 degrees plus angle EDA must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle equals to 180 degrees minus 90 degrees, it is 90 degrees. So this is the missing angle EDA that is equal to 90 degrees, therefore the green triangle AED is the right triangle. So you can implement the Pythagoras theorem on the green right triangle EDA. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, according to the Pythagoras theorem. So here we will get that AE square equals to AD square plus ED square. In the right triangle ADA, according to the Pythagoras theorem, AE square equals to AD square plus ED square. AE equals to 1 plus A, therefore A square is 1 plus A square. AD equals to 3, so AD square is 3 square, that is 9, plus ED square. ED equals to A, so ED square is A square. So in conclusion, we found out that according to equation number 2, 1 plus A square equals to 9 plus A square. We open the brackets on this side of equation number 2, and we got that 1 plus A square equals to 1 plus A square plus 2A, that is equal to 9 plus A square. We have A square on both sides of the equation number 2, so A square will get cancelled, and we left only with 1 plus 2A, that is equal to 9. We subtracted 1 from this equation number 2, and found out that 2A equals to 9 minus 1, that is 8. So 2A equals to 8. We divided equation number 2 by 2, and we got that A equals to 8 over 2, that is 4. So we found out that A equals to 4, therefore A plus 1 is 5. Then actually here we defined angle BEC, this angle is alpha. And in the green triangle, right triangle AED, cosine alpha equals to ED or EA. Here, in triangle AED, cosine alpha equals to ED over AE. ED equals to 4, A equals to 5. So in conclusion, found out that cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in this triangle, triangle ABC. Triangle EBC. So what is the law of cosines? The law of cosines is true in any triangle. If we have triangle ABC, that could be any triangle. And so this is triangle ABC. Side AB equals to A units in its length, side AC equals to B units, and side BC equals to C units in its length. And we know that the angle between side BA and side AC is alpha. So here, according to the law of cosines, we get that C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. This equation is true in any triangle. So we implemented the law of cosines in this triangle, triangle EBC. Here, A equals to EB, B equals to EC, and C equals to BC. And we already found out that cosine alpha equals to 4 over 5. EB equals to 5 plus 5, that is 10. EC equals to 4 plus 6, that is also 10. So we get that according to the law of cosines, EB squared, actually according to the law of cosines, BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Okay, BC equals to x according to what is given us in the question, therefore BC squared is x squared, and it is equal to EB squared. EB is 10, so EB squared, it is 10 squared, that is 100, plus EC squared. EC is 10, so EC squared is 100 also, minus 2 times EB is 10, and EC is also 10, so it is minus 2 times 10, and cosine alpha is 4 over 5, so we substituted cosine alpha by 4 over 5. So in conclusion, this expression equals to minus 2 times 10 times 10 times 4 over 5. So here we have, according to equation number 3, x squared equals to 100 plus 100 is 200, and here 10 times 10 is 100, and 100 times 2 is minus 200 times 4 over 5. And minus 200 over 5 is minus 40. So this expression will be equal to minus 40 times 4. So in conclusion, we found out that x squared equals to 200 minus 40 times 4. 40 times 4 is minus 100, minus 40 times 4 is minus 160. So in conclusion, we found out that according to equation number 4, x squared equals to 200 minus 160. 200 minus 160 is 40, so we got that according to equation number 3, x squared equals to 40. We took out of this equation, equation number 3, and found out that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Here, x equals to either 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Then I presented to you how to find out the length of line segment BC that is equal to x according to the second method. In the second method, we did another construction. From point A, we draw a straight line on DC in such a way that AE will be parallel to BC. I'll repeat again that AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that EF will be parallel to AB. Again, EF is parallel to AB according to our construction. So here we created quadrilateral AEBF is a parallelogram. Why? Because it has two couples of sides that are parallel to each other. So quadrilateral AEBF is a parallelogram. Okay. Then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. And we know that here AB is parallel to EF according to our construction. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AB and EF will be equal to each other according to rule number 3. Okay, so because of the fact that AB is parallel to EF according to our construction, then angle ABC will be equal to angle EFC according to rule number 3. But it is given us the question that this angle ABC equals to theta. So from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equal to theta. So this angle EFC equals to theta. Likewise, according to our construction, AE is parallel to BC. Therefore, according to rule number 3, the two angles that are angle AED and angle DCB that are defined as corresponding angles, they will be equal to each other. I'll repeat again. According to our construction, AE is parallel to BC. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines A and BC will be equal to each other. That is to say, according to rule number 3, of course, angle AD equals to angle DCB. But this angle DCB equals to theta according to what is given in the question. So here, angle DCB equals to theta. So from this equation, theta equals to angle BCD equals to angle AD, we derive that angle AED, this angle, it is also equals to theta. Okay. Then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So if we relate to our parallelogram AEBF, we know that the opposite sides of this parallelogram are equal to each other. That is to say, AB equals to EF, according to rule number 4. The parallelogram ABF, AB equals to EF, according to rule number 4. But AB equals to 5 units. It is given us the question. AB equals to 5 units. So here, from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. Here, EF also equals to 5 units. Then, in triangle EFC, We know that those two angles are equal to each other, they are both equal to theta. Therefore, according to rule number 1 that states that in front of equal angles in a triangle there are equal sides, we get that EF equals to EC. Okay? According to rule number 1, EF equals to EC. But we just right now found out that EF equals to 5. So can I tell that EF equals to 5, and from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5. Okay? So what is the length of the small line segment DE? From the drawing it is very easy to see that DC minus EC equals to DE. Again, DC minus EC equals to DE. Okay, here DE equals to DC minus EC. So DE equals to DC, that is 6 units, minus EC, that is 5 units. That is to say DE equals to 6 minus 5, that is 1. So here the small line segment DE equals to 1 unit. Then we implemented the Pythagoras theorem on the small right triangle, triangle ADE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus DE square. So AE square, it is the square of the hypotenuse, equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is 1. So in conclusion, we found out that AE square equals to 9 plus 1, that is 10, so AE square equals to 10, according to equation number 1. We took out of this equation number 1, and we found out that A equals to the square root of 10 units. Here, A equals to the square root of 10 units. Then we implemented rule number 4 in the parallelogram AEBF, that the opposite sides of a parallelogram are equal to each other. That is to say, A equals to BF. I repeat again, in parallelogram AEBF, according to rule number 4, A equals to BF. But we just right now found out that A equals to the square root of 10 units. So from this equation, square root of 10 units equals to A equals to BF, we will derive that BF is also equals to the square root of 10 units. Okay, BF is also equals to the square root of 10 units. And so if BF equals to the square root of 10 units and BC equals to X, what is the value of FC? It is very simple to see from the drawing that BC minus BF equals to FC. Again, BC minus BF equals to FC. Yeah, FC equals to BC minus BF. BC equals to X according to what is given in the question. And we just right now found out that BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So can I tell that FC equals to X minus square root of 10 units? Then we focus on the isosceles triangle, triangle EFC. First of all, triangle EFC, this triangle is an isosceles triangle because of the fact that side EF equals to side EC, equals to 5 units. Triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. Therefore, FC is the best of the isosceles triangle, triangle EFC. And then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, but before that, from point E we draw perpendicular on FC. That is to say, this angle equals 90 degrees and this angle equals 90 degrees according to our construction. So EM is perpendicular to FC, that is to say EM is the height to the base FC. Okay, EM is the I to the base FC. Here you can see EM is the I to the base FC. Then I presented to you rule number 5. Then the I to the base in an isosceles triangle bisect the base. So according to rule number 5, if we relate to the isosceles triangle, triangle EFC, the height EM to the base FC bisects the base. That is to say, it divides the base into two equal parts. That is to say, Fm equals to MC. So first of all, Fm equals to MC according to rule number 5. And the meaning that it bisects the base, it means that it divides it into two equal parts. So if Fc equals to 1, it means that it divides it to 2 halves. Then it means that Fm will be equal to Fc over 2, and MC will be also equal to Fc over 2 because of the fact that it divides the base Fc into two equal parts. If it divides the base Fc into two equal parts, it means that each part must be equal to Fc over 2. So Fm equals to Fc over 2 and MC also equals to Fc over 2. So in conclusion, I found out that Fm equals to Fc over 2 and MC equals to Fc over 2. So in conclusion, Fc over 2 equals to Fm equals to MC according to rule number 5. So MC equals to Fc over 2. And we know that Fc equals to x minus square root of 10. So MC equals to Fc, that is x minus square root of 10 over 2. So Fc over 2 equals to MC. Fc is x minus square root of 10, and if we divide it by 2, we will get MC. In conclusion, we found out that MC equals to x minus square root of 10 over 2. So here MC equals to x minus square root of 10 over 2. Then we proved that those two right green triangles are similar to each other. Why those two green right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees, therefore they are equal to each other. Those two angles, they are both equal to theta, therefore they are equal to each other. In this right triangle, this angle equals to 90 degrees, this angle equals to theta, therefore this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. This angle must be equal to 90 degrees minus theta, and for the same reason exactly, this angle must be also equal to 90 degrees minus theta. So we have those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we have three angles in these right triangles that we can go to three angles in these right triangles. Those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Those two angles, they are both equal to 90 degrees, therefore they are equal to each other. And those two angles, they are both equal to theta, therefore they are equal to each other. So, therefore, triangle ADE is similar to triangle EMC according to angle similarity rule. Triangle ADE is similar to triangle EMC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we conclude that AE over AC equals to DE over MC. I will repeat again. We conclude that AE over EC equals to DE over MC. AE equals to the square root of 10 units. EC equals to 5. DE equals to 1 and MC equals to x minus square root of 2 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator on this side of equation number 2. And found out that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we cross multiply this equation number 2, and we got that square root of 10 times x minus square root of 10 equals to 10. But 10 is square root of 10 times square root of 10. So we substitute the 10 by square root of 10 times square root of 10. And we got that square root of 10 times x minus square square root of 10 equals to the square root of 10 times square root of 10. Then we divided this equation number 2 by square root of 10, and we got that square root of 10 times square root of 10 is 1, so what is left on this side of equation number 2 is only x minus square root of 10, and here square root of 10 times square root of 10 over square root of 10 is square root of 10. So in conclusion, we found out that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation in equation number 2, and we got that x equals to square root of 10 times, plus square root of 10 is 2 times square root of 10, or in terms of numbers, it is equal to 6.32 units. So in conclusion, we found out that the length of line segment BX that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so in both methods, we found out that the length of line segment BC that is equal to x, it is either 2 times square root of 10 units, or in terms of numbers, it is 6.32 units. Okay, thank you very much.